Okay, 4.3, part 3, day 2. We're going to look at the second derivative test for local extreme values. And honestly, today, what we're going to go over is going to be used on the extremely rare case. It's going to be used when you have limited info available. So whether it be a table of values or really probably where it's going to pop up is going to be an implicit problem. And it's where we can't tell for sure that a change in sign occurs on the first derivative. So like I said, this is going to be an extremely rare case. Most likely, it's going to be an implicit problem. Could also possibly be a table of values problem on the AP test. You have these two scenarios here. Again, you could memorize these if you wanted to, but I like to think through it logically when I'm given a problem. The key here, though, absolute what you have to have memorized is that we need the first derivative to equal 0. Okay, so in order for like any of these like local extremes to occur, your first derivative has to equal 0. And we know that going back to previous sections because when the first derivative is 0, tangent line 0 means there's a change in direction going on. We're switching from increase, decrease, vice versa. But with these, the first little point says first derivative is 0 and the second derivative, so here's my second derivative is negative. We're going to have a local max. The way you think about this logically, at least I do, second derivative is going to tell me the concavity. So if it's concave down, negative, concave down, opening down, you have to have a max. So that makes sense. The other way, you have first derivative 0. If the second derivative is greater than 0, then we have a local min. So this one, they change it up a little bit. You got point C over here, C's over here. I look at the second derivative. First off, the first derivative is 0. Okay. Second derivative positive means that we're opening up. So if we're concave up, we have to have a low point. So there has to be a minimum. Again, you could have those two bullet points memorized. Like I said, you're better off just thinking through these problems logically. So number 7 is just a basic one to show us what the heck's going on. Given first derivative 0. Okay, cool. We got that going on. Second derivative is given by the function 2x plus 2. We want to determine is going to have a local max or min. So let's go ahead and plug in negative 3 to my second derivative. Doing that, 2 times negative 3 is negative 6, plus 2 is a negative 4. Okay, so I got that right there. We think about what the second derivative tells us. It tells us concavity. So if it's negative, that tells me that we have a concave down, which means the function's opening down. So think about it. If the function's opening down, we're going to have a high point. So that means we're going to have a max. Writing this out, we're going to say f has local max at x equals negative 3. And then here comes the justification. Because you have to tell me that the first derivative at that point is 0. If you don't tell me that the first derivative at x equals negative 3 is 0, the whole justification is garbage. Okay, so because the first derivative is 0 and our second derivative at negative 3 is negative. Okay, and if you want to throw in there, you could also say it's a second derivative test. But honestly, that first up here, that's good enough for your justification. Absolutely have to tell me that the first derivative is 0. If you don't, we're not getting points at all. B says given f prime 1 equals 0. So again, there's my key. You need to know the first derivative is 0. Determine if f will have a relative min or max at x equals 1. So we go back to our second derivative. Let's go ahead and plug in 1. Plugging in 1. Back up to this one right up here. 2 times 1 is 2 plus 2 is 4. So it's positive. We know from the first day that concave up occurs when the second derivative is positive. So if I'm concaving up, we're going to have a local min. So we can say f has a local min at x equals 1 because, again, first derivative at 1 is 0 and our second derivative is positive. That's it right there. Okay, so those two basic problems right there, just to show you like what we are dealing with. This number 8 is an actual AP question. This is kind of cool because we're getting to the point where we're able to do these AP questions without altering them. So this is straight from a previous test. A little bit into scoring. All AP free exam questions are going to be worth 9 points. And I can't spell. That probably helped. 9 points. And typically there are 3 or 4 parts. So looking at this one, it's broken up into A, B, and C. Each of these parts are 3 points each. And on the AP exam, it's kind of a game where we're trying to get every point we can possibly get. And remember, it pays to show work. Okay, so you need to show your work. You need to show your thinking. If you don't do that, you're not going to get full credit. So A, I want you to find dy dx. That goes back prior weeks. Okay, dy dx, we're just taking the derivative. So doing the derivative of this, you're going to end up with 2y. Derivative of y is dy dx plus 6x equals, we got a product rule now. So I got my first 3x times derivative of second, so dy dx plus second, so I got y times 3. Derivative of 1 is 0, so it's gone. Thinking back to your implicit differentiation, you need to get the dy dx's to one side, so I'm going to move the dy dx's to the left. And then move my other terms to the right, so I'm going to have 3y minus 6x. From here, you're going to GCF the dy dx out, so I got dy dx 2y minus 3x equals 3y minus 6x. And then to get dy dx by itself, you divide the 2y minus 3x over. So dy dx equals 3y minus 6x over 2y minus 3x. That's my answer. And on the AP exam, you want to show all of your work because you are getting points along the way. So that right there is 3 points. We're starting off in good shape. Part B is where we're going to start getting a little more difficult. You want to show that there's a point A. Okay, so here's the key. I want to show that there's a point A. X coordinate 1, at which the line tangent to the curve at A is horizontal. You also have to find the y coordinate of A. So you got a lot going on here. Again, we get points along the way. So let's say you're absolutely lost. Remember, we do get credit for showing our starting point. So we got dy dx. We're going to be dealing with the previous one. That's my slope tangent line. 3y minus 6x over 2y minus 3x equals 0. And that's because we're dealing with a horizontal tangent line. So the derivative of the slope equals 0 because it's horizontal. From there, we need to solve. Okay, so when a fraction is going to equal 0, that's going to be when the numerator equals 0. So I got 3y minus 6x equals 0. In the problem, they tell us that our x coordinate is 1. So I'm going to go ahead and substitute 1 in for x. And we go ahead and solve. So you get 3y equals 6, y equals 2. Okay, so we're going to get the point A, 1, comma 2. That's our point. Now for this, depending on how picky they are, you probably do want to show that the point actually does lie on the curve. So to show that the point lies on the curve, you're going to go all the way back up to your original function. And we're going to plug in. So you got 2 squared plus 3, 1 squared equals 3 times 1 times 2 plus 1. And when we work it out, you're going to get 7 equals 7. So that actually shows us that A is on the original curve. Okay, so that works out. That would be a full 3 points. So they get the problem of the 9. We're at 6 already, so we're off to a great start. Last part of this problem, 3 more points. Part C, they want you to find the value of d2y dx2, so that's the second derivative, at the point from part B, so we're dealing with the point from part B, or 1, 2. You want to know, does the curve have a local max, local min, or neither at this point? Explain your reasoning. So this is where we need to start thinking through it, okay? At the point from part B, it's a horizontal tangent line, so I know right away that f prime equals 0 at point A. So we got that going on. And in this problem, they ask you for the second derivative. So if they ask me the second derivative, we're doing the second derivative test we just learned, okay? So let's go ahead and do that. To take the second derivative is going to be a little bit of a pain because our first derivative was a quotient. So we're going to have to do the quotient rule. You got bottom times derivative top. So derivative of the numerator, you got 3 dy dx minus 6. And then we got minus top. Derivative bottom. Derivative of the bottom is going to be 2 dy dx minus 3. And that is all over denominator squared. Okay, a couple of cool things about this problem. They ask you to find the value. Okay, so the actual value of the second derivative. So we don't need to simplify this actually down at all. We're just going to plug in and find the value. The second thing that's cool is we know at point A, dy dx, my first derivative is 0. So instead of having to substitute in for dy dx, since we're evaluating a value, we know that each of these dy dx's goes to 0. Okay, so that's going to make our life a heck of a lot easier. Evaluating, I'm going to take second derivative. I'm going to say I'm going to evaluate it at 1, 2. Okay, so that's the notation we use there, evaluate at 1, 2. And let's go ahead and actually show that we're plugging it in. Okay, so you got 2 times 2 minus 3 times 1. 3 times 0 minus 6. You got 3 times 2 minus 6 times 1. 2 times 0 minus 3. And then we are all over 2 times 2 minus 3 times 1. And then we're squaring that whole mess. All right, when you work this whole thing out, you should get an answer of -6. So I'm going to say, hey, when we evaluated that at the point 1, 2, we get a value of -6. And that allows us to go into our justification. So we're going to say that the curve has a local max at 1, 2 because our first derivative equals 0. And think about it, if I'm concave down, okay, so I kind of jumped a step there, but if I'm concave down, we are going to have a high point. Okay, we're going to have a max. That's why we're able to say the max. First derivative is 0, and our second derivative is negative. Okay, so that's 9 points for us on our AP exam. So honestly, that's probably the most important problem for this section of the notes.